Good day to all. Today we are going to see about that external gear pump. This is the diagram of that gear pump. See here it's a low pressure inlet, high pressure exit, which means it will come from that fluid reservoir without pressure. That's why here it indicates low pressure inlet. And after coming out, it will come high pressure. The output of this high pressure oil, it will connected to control valve or relief valve like that. Then that will connected to the piston according to our applications. Here you can see some white arrow inside this bearing. See here this arrow indicates that fluid path. The fluid will flow here to here likewise. The main operation of this external gear is as the gears come out of mesh of that inlet side of the pump, they create an expand volume. See here, if it is rotate like this, if the motor is on, then it will rotate like this, here to here and here to here. Here there is one expand volume will create. Due to this expand volume, this oil will get pressurized. See, they create an expand volume. Liquid flows into the cavities and it's trapped by the gear tread as the gears continue to rotate against the pump casing. The trapped fluid is moved from the inlet to the discharge around the casing. As the teeth of the gears become interlocked of the discharge side of the pump, the volume is reduced and the fluid is forced out under the pressure. Here the main thing, see, as the teeth of the gear becomes interlocked on the discharge side of the pump, the volume is reduced and it will have pressure. The volume is reduced. Why? Because of that interlock of that particular gear. Then we will get a pressurized output of the outside of that particular pump. See, this part is interlocked with the gears. Here it's interlocked. So here the volume is expand and the volume is reduced here. Volume reduced and we will have a high pressure in that outside of that particular gear pump. These things of external gear pump. Then we will going to see about that internal gear pump. See, the internal gear pump is have a inside of that particular bearing. In the external gear pump, the two bearings are connected externally, but here it is connected with that internally with the idler, and the outside of that gearing is called rotor. From the rotors, the operation will have the fluid path. Here is, you can see here the fluid path will come here and it will go like this and it will go like this. These are all the flow path of that this particular internal gear pump. We will see the operation of the gear pump. The both external and the internal gear pump operation are same. In some changes are there because of that connection of internal. See here also, as the gears come out from that mesh inside of the pump, they create an expand valve. Liquid flows to the cavities, strapped gear teeth, and the gear continue rotate against the pump casing. On the portion here, the main thing is there is a no partition in that external gear pump, but here it's a partition in that internal gear pump. This is the main difference from that external as well as internal gear pump. Remaining things are the same from that external gear pump. The trapped fluid is moved from the inlet to the discharge around the casting. As the teeth gears become interlocked on the discharge side of the pump, the volume is reduced and the fluid force out under pressure. These are all the things about the internal and external gear pump. This is the another pump. There are various pumps are there for that fluid system. These are all vary with that construction. See here the construction how it will look like this. This will rotate and the fluid path will flow like here. If it is rotate, then the oil will become pressurized. This is the intake, which means the oil reservoir oil coming from here, and will have a output which means pressurized oil from here. This is the loop pump, and also another pump is also there, which is screw pump. The operation will inside of this screw pump, it will have a screw like this. See timing here and the power input shaft. This screw pump will have a pressurized oil because of this timing here. This timing gear will tighten to this screw. When the screw is tightened, this oil will become pressurized and it will go to outside. Here the inside of that particular oil, this is the outside of the particular oil. The way of that oil. This is the inside and this one is that outside. Then the another pump is van pump. See, these are all the pumps are having the same procedure, but the thing is the construction wise both are all different, as well as the application wise also all pumps are different. Some will have some pressurized one, will have some high pressure in that some pump, will have low pressure in that some pump, as well as we'll see about the cost wise of this pump also. Here in this van pump, see this is the inlet. The inside the van pumps, the vans are connected. More number of vans connected outside of the shaft. The oil flow from this van pump coming from here to here. You can see the oil path. This is the inlet, the oil coming from that reservoir, and it will go like this, and we will get the pressurized output of that oil here. This is the operation of that van pump. Here also the rotor point is there. This is the rotor point. In that rotor which connected with that shaft. If the motor is on, rotor will rotate. With the help of this rotor, the van also will have give a pressure to that inlet oil. From that unpressurized inlet oil will have a pressurized output oil with the help of this interconnection of that van pump. These are all the more number of applications for that hydraulic system. As I said before, all our pumps used to have a give pressure to the particular oil, because depend upon that pressurized oil will have output in that hydraulic system, which means in that piston movement and the return of that pistons, this will occur with the help of this particular oil. So in that oil we'll have that operations of the particular pump. These are all the things about the pump. Thank you.